All right, the last two lessons here are a little bit of actually a lot different than the first four lessons in this unit. We're going to take basically a break from equations and move to inequalities. Okay, so recall inequalities from unit 2. Remember I said show all solutions for the inequality x is greater than 4, right? And I put a 0 here, and 4 was to the right. We put an open circle, and we shaded the numbers to the right of 4. Okay? Remember what I said about an inequality. An inequality has infinitely many solutions, right? Which is why we need to graph or shade. Okay, because we want to show all the solutions, we need to graph or shade, like I did here. All the numbers bigger than 4, well, there's lots of them. There's an infinite number of them bigger than 4. To show them all, add shade. Okay, so new stuff. So I'm taking old stuff, going to new stuff, but it's got a lot in common. In the inequality above, how many variables does the inequality have? It had 1. What does the solution look like? A number, right? A single number. Today we'll be working with inequalities involving 2 variables, which means a solution will look like an ordered pair, just like with our solutions to a system. Our solutions are going to look like x, y points. Okay? Show all solutions to the following inequality. Okay? Now I'm going to ignore the inequality. I'm going to graph this like I graphed in Unit 4. So y-intercept of 3, slope of 1/2. So 3, up 1, right 2. Up 1, right 2. Up 1, right 2. Okay? Now before I do that, actually, no, I'm going to go ahead and graph it. Okay? It says show all solutions to the following inequality. Okay, now I'm going to go through these questions here first. Determine if the given point is a solution to the inequality. 0, 0. So I'm going to put 0, 0 in, and I'm going to see if that's true. So I'm going to see if, when I put 0 in for y, is this a true statement or a false statement? So 1/2 of 0 is 0. 0 plus 3 is 3. Is 0 bigger than 3? No. -2, 7. I'm going to put the same thing in. So I'm going to put 7 in for y. 1/2 of -2 plus 3. 1/2 of -2 is -1. -1 plus 3 is 2. Is 7 bigger than 2? Yes. And then 4, 5. I'm going to put 4 in for x and 5 in for y. So 1/2 of 4 is 2. 2 plus 3 is 5. Is that a true statement? Is 5 bigger than or equal to 5? Yes. But if that line weren't there, this would be a no. Okay? Now, I want to shade all my solutions. So -2, 7 is a solution. So -2, 7 is a solution. 0, 0 was not. 4, 5 was. Can you, hopefully you're understanding here what's going on. This line is the boundary that separates the solutions from the non-solutions. Think of it like a fence. On one side of the fence is the solutions. On the other side are the non-solutions. So what I can tell here is that's not a solution. That is. That means this side of the line, this side of the fence is the solutions. All of those points. And they don't just stop right here. They go on forever. Okay? Just like up here, the 4 wasn't a solution, but it separated the solutions from the non-solutions. That's what this line is doing. Now in this case, the numbers on the line, so 4, 5 was my example, was a solution. And the way we show that is making a solid line, which is why I hesitated when I drew the line. If that wasn't equal to, this would be no, and then this line would be dotted, kind of like an open circle. Okay, so I know I said that all very quickly. I'm going to go over that again as we go. Notice that the process is almost exactly like graphing lines except for two things. You must make your line either solid, okay, and this was a solid line because it was equal to. So it can be greater than or equal to or less than or equal to. Doesn't really matter. It's got to be equal to though. Or dotted, and the dotted does not have the equal to's. We'll do dotted on the back. The line separates the solutions from the non-solutions. Okay? You must shade on one side of your line. Okay? The shaded region represents all the solutions to the inequality. Okay, so we're going to practice on the back. To determine which side to shade, you must have your inequality in slope-intercept form. Okay, so that, for those of you that don't know what that is, that's y equals mx plus b. Okay, if the symbol is greater than, either one, either greater than or equal to or greater than, it doesn't really matter, you shade north. I call it north. Or up. If the symbol is less than, either equal to or not equal to, then you shade south or down. So now let's practice. So again, ignore the sign for now, but actually no, I'm not going to ignore the sign. What I would do, now that I've introduced solid versus dotted, I would look at this and say, oh, that's going to be a dotted line, and I would write it out. Because there's nothing worse than drawing a solid line and be like, oh crap, it's supposed to be dotted, and having to erase. Okay, so I know it's going to be dotted. I'm going to write that down so I won't forget it. Now I'm going to ignore it, and I'm going to graph like I normally would. Go up to 7. I go down 2, right 3. Do it again. And now I'm going to draw a dotted line through that. Okay, it was already in slope-intercept form. It's greater than, so I shade north. What I mean by that is, if I put my pencil on the line or pen, and I go straight north, so straight up from that point, I'm getting to my shaded region. Now that's going to come in nicely when I have a really steep line, like I'm going to have here. Okay, so when I do this one, I see that this one's going to be a solid line, which means, I should probably stop and explain this. If it's a solid line, that means a point on the line is a solution. If I have a dotted line, a point on the line is not a solution. Okay? So a solid line, I go down to 1, go up 5, over 1. Solid line, so I'm going to go ahead and get my... Okay? On the previous example, it wasn't really hard to see what was up and what was down. But this one it is. It's so steep, what's up and what's down? First of all, I know I need to go down. I need to go south. So if I put my pen on the line anywhere, it doesn't have to be there, but anywhere on the line, and I draw straight down, I've gone to my shaded region. And that hopefully helps people see that this is the shaded region. And we're done with that. Okay? Excuse me. Give just one solution to this inequality. Okay? There's lots. Again, there's a bunch of them. But I want to pick a point in that shaded region. So I'm just going to say 7, 7. And you can check it to make sure, but put 7 in for x, 7 in for y, and you should get 7 bigger than whatever this number ends up being. Same thing here. I'm going to pick any point that's in the shaded region. So I'm just going to say, I don't know, 5, 0. Okay? And that should work if I plug it in. Okay? Next two. What do you have to do first for these two? You have to put them in slope-intercept form. Okay? And you're going to see why with number 4 here. So let's start with number 3. Get it in slope-intercept form. I'm going to subtract 4x. So I get 3y is greater than or equal to negative 4x plus 9. Divide by 3. I get y. Actually, no, new inequality, I'm just going to write it. Y is greater than or equal to negative 4/3 x plus 3. It's going to be a solid line. Okay, I'm going to go up to 3, down 4, right 3, do it again, up 4, right 3. Solid line, so I'm going to go ahead and draw that with my straight edge here. Okay, and now I shade north, greater than is north, so up here. Okay, now notice my next question. Is 3, -1 a solution? So 3, -1, that's on the line. Is it a solution here? Yes, it is, because it is a solid line, which means when I put 3 in for x, I'm going to get -1 for y, but that's okay since it can be equal. Okay, so yes. Next one, I'm going to move 4x, so I'm going to have -6y is greater than -4x plus 24. Divide by -6. But remember, as soon as you divide by a negative, flips the sign. Okay, so I'm going to have y is less than positive 2/3 x minus 4. Now, this is why it's important that it's in slope-intercept form. Because if you graph it here, you would shade north. But when you get it in slope-intercept form, look what happens. It switches and you shade south. So I'm going to go -4, up 2, right 3, up 2, right 3. Oh, and before I do anything, I can't forget that. It's a dotted line. Okay. Is 6, 0 a solution? So that's, again, on the line. Is that a solution? Oh, wait, before I do that, I'm going to shade south. Is that a solution? No. Even though it was on the line, just like this one was, something on the line here is not a solution, but it is when it's solid. And that is linear inequalities. Let me know if you have any questions.